In this lecture, we are going to talk about maybe the most important interview question as far as one-dimensional arrays are concerned. So we have an array of integers, and the problem is that we would like to design an algorithm that's going to reverse the order of the integers within this given array, and this algorithm must be in place, which means that we have to design an algorithm without any extra memory. So what do we have to do? We just have to use two pointers, two variables, the start index and the end index. At the beginning, the start index will be pointing to the first item of the array. The end index will be pointing to the last item of the array. What do we have to do? We just have to swap these items. So 5 will be 1 and 1 will be 5 accordingly. Then we have to increment the start index and we have to decrement the end index. Again, we have to swap the values, so 2 will be 4, 4 will be 2, and again we have to do it until the start index is not smaller than the end index. So in this case, both start index and end index are pointing to the same item, which means that the start index is equals to the end index, and this is when we know that we have to terminate the algorithm, because as you can see, we have managed to reverse the given array with an in-place algorithm. There is no need for extra memory. So let's take a look at how to implement this problem. First of all, let's define a function for reverse, and we get a nums, a list data structure we would like to revert. So first of all, we have to define the starting index. At the beginning, it is pointing to the first item in the data structure with index 0, because indices starts with 0. And of course, we have the end index that is pointing to the last item of the data structure. And of course, we can get the number of items in the list data structure and -1 because indices starts with 0. Okay, so this is the pointing to the first item. We have the index pointing to the last item. And what do we have to do? While the end index is greater than the start index, what do we have to do? Basically, we have to keep swapping the items. So we have the nums. As far as the start index is concerned, we have the nums as far as the end index is concerned, and it is equals to the approximately the same, but of course we have to make sure that we swap the items. So the end index will be the start index and the start index will be the end index. So this is how we swap two items in the underlying list data structure. Then of course, what do we have to do? We have to increment the start index by 1, and we have to decrement the end index by 1. And basically, that's all about the algorithm. This is what we have been talking about. Start index pointing to the first item, end index is pointing to the last item. Then we have to swap them, and then we have to increment the start index and decrement the end index until both of these pointers are pointing to the same location. So let's see whether it is working fine. So if the name is equals to the main, so we have the main function, we have a list data structure 1, 2, 3, 4, for example. We call the reverse function on n, and then we print out n. So let's see whether it is working fine or not. So if we run the algorithm, 4, 3, 2, and 1. So as you can see, we have managed to achieve our goal as far as reverting the given underlying list data structure is concerned. And of course, we have just -3, 0, and 3, for example. Let's see whether it is going to work just fine. Yeah, it is going to work just fine. So this is how we can solve this problem with the help of two pointers. We have a starting index pointing to the first item in the data structure. We have the end index pointing to the last item in the data structure, and we have to iterate and keep swapping the items while the end index is greater than the starting index. So this is how we solve this problem. Thanks for watching.